Let's denote the given integral by I. Now let phi is equal to half of pi upon 4 plus 3 pi upon 4 minus u. This simplifies to pi upon 2 minus u. Taking the derivative of both sides, we get d phi is equal to minus du. Now when phi is equal to the lower limit pi upon 4, u is equal to pi upon 2 minus pi upon 4, which is equal to pi upon 4. And when phi is equal to the upper limit 3 pi upon 4, u is equal to pi upon 2 minus 3 pi upon 4, which is equal to minus pi upon 4. Using these results, I can be written as integral u going from pi upon 4 to minus pi upon 4 minus du pi upon 2 minus u in the numerator, and the denominator is 1 plus sine of pi upon 2 minus u. Reversing the limits, which introduces a minus sign, we get minus integral minus pi upon 4 to pi upon 4 minus of pi upon 2 minus u du divided by 1 plus cos u. I can therefore be broken into two parts. The first part is integral minus pi upon 4 to pi upon 4 pi upon 2 du divided by 1 plus cos u. And the second component is minus integral minus pi upon 4 to pi upon 4 u du divided by 1 plus cos u. Now let's denote the integrand in the first term by fu. Note that f of minus u is equal to pi upon 2 divided by 1 plus cos of minus u. Cos of minus u is equal to cos u, and therefore f of minus u is equal to pi upon 2 divided by 1 plus cos u, which is equal to fu. In other words, fu is an even function, and therefore using properties of definite integrals, integral minus pi upon 4 to pi upon 4 fu du is equal to 2 times integral 0 to pi upon 4 fu du. Now denote the integrand in the second term in the expression for I by gu. So gu is equal to u upon 1 plus cos u, and therefore g of minus u is equal to minus u divided by 1 plus cos of minus u, which is equal to minus u upon 1 plus cos u, which is equal to minus gu. Therefore gu is an odd function, and again using properties of definite integrals, integral minus pi upon 4 to pi upon 4 gu du is equal to 0. Therefore the expression for I simplifies to pi upon 2 times integral 0 to pi upon 4 du upon 1 plus cos u. Now let tan u upon 2 be equal to t. Taking the derivative of both sides, we get half of sec square u upon 2 du is equal to dt. When u is equal to the lower limit 0, t is equal to tan of 0, which is equal to 0. And when u is equal to the upper limit pi upon 4, t is equal to tan of pi upon 8. Cos of u can be written as 1 minus tan square u upon 2 divided by 1 plus tan square u upon 2, which can also be expressed as 1 minus t square upon 1 plus t square. Using these results, I can be written as pi times integral t going from 0 to tan pi upon 8. Du can be replaced with 2 dt upon sec square u upon 2, but sec square u upon 2 is equal to 1 plus tan square u upon 2. And therefore du can be replaced with 2 dt upon 1 plus t square. And 1 plus cos u can be replaced with 1 plus 1 minus t square upon 1 plus t square. This simplifies to 2 pi times integral 0 to tan pi upon 8 dt upon 1 plus t square plus 1 minus t square. This is equal to 2 pi upon 2 integral 0 to tan pi upon 8 dt, which simplifies to pi times tan pi upon 8. Now to evaluate tan pi upon 8, we note that pi upon 4 can be written as the sum of pi upon 8 and pi upon 8. Take the tan of both sides, we get tan of pi upon 4, which is equal to 1, is equal to tan of pi upon 8 plus pi upon 8. The right hand side can be written as 2 tan pi upon 8 divided by 1 minus tan square pi upon 8. Cross multiplying, this can be written as 1 minus tan square pi upon 8 is equal to 2 tan pi upon 8. Moving all the terms to the right hand side, we get tan square pi upon 8 plus 2 times tan of pi upon 8 minus 1 is equal to 0. This is a quadratic in tan pi upon 8. So solving for tan pi upon 8, we get minus 2 plus minus root of 2 square minus 4 times minus 1 times 1. All of this divided by 2. And this simplifies to minus 2 plus minus 2 root 2 divided by 2. And therefore the possible values of tan pi upon 8 are minus 1 plus root 2 and minus 1 minus root 2. Now note that pi upon 8 lies in the first quadrant, and tan of an angle is positive when the angle is in the first quadrant. Therefore tan of pi upon 8 must be positive, and therefore the root minus 1 minus root 2 can be ruled out because it's negative. Therefore tan of pi upon 8 is equal to root 2 minus 1. Using this result, the value of I is equal to pi times root 2 minus 1, which is the required answer.